Thank you for joining the January 2024 VMware TAM customer webinar. This webinar is organized by the VMware TAM organization to provide our customers the opportunity to hear great content and interact directly with the great speakers that are delivering it, with the goal of making sure that you are getting the full benefit from your software. Please make use of the Q&A feature to ask any questions, and if your question doesn't get addressed today, be sure and reach out to your TAM and ask them to follow up. Before we get into today's content, there are just a couple of basic announcements. Our next TAM customer webinar will be on February the 8th, and we'll have the privilege of being joined by Brock Peterson to talk about ARIA operations. As I mentioned earlier, we want you to benefit from these sessions by interacting with the speaker. So if you have any question during today's webinar, please use the Q&A feature of Zoom and we will address them during the webinar. At the end of today's session, you'll be prompted to fill out a simple 2-question survey related to the value you received from this session and any topic suggestions for the future. Your completion of this survey is a very valuable gift back to us, and we'd greatly appreciate it. And lastly, this webinar is being recorded, and your TAM can make the recording link available to you. After a few months, the recording will be publicly available on the VMware TAM Services YouTube channel. That brings us to today's speaker and topic. Shobhit is a principal product marketing manager, and Justin is a staff technical marketing architect, both with the VMware Cloud Foundation Group at VMware. Shobhit, please go ahead.
Yeah, thank you so much, Brian. I'm Shobhit. I work in VMware as the product marketing lead for AI ML. Been in VMware about 2 years or so, and recently led the launch of VMware, VMware Private AI. In 2023 in Las Vegas, and then the NVIDIA offering, and then Intel and IBM. So that's a little bit about myself. Justin?
Hi, good morning. Justin Murray, technical marketing at Broadcom, working closely with Shobhit and the team on democratizing AI.
Wonderful. Brian, you want us to get started, or anything else you want to set up the meeting with?
Nope, that should be good. Feel free to take it away.
All right, sounds great. So thanks once again, team, for the opportunity to present here. Today, we're going to really cover these topics. We're going to talk about AI and generative AI and why it's important, the challenges that are there in AI today. What is VMware Private AI, right? And then the 3 offerings, Intel, IBM, NVIDIA, and after the NVIDIA section there's going to be a technical deep dive that Justin's going to present on VMware Private AI. And finally, we'll end with resources. So that's a little about how the order is going to be. And then at the NVIDIA offering is where Justin will take over and take us home and present the technical deep dive and then go take to the end. So with that, let's jump in. Let's build this out. There you go. So over the course of last 30 years or so, right, there's been several ways that applications have innovated. If you go back to like 30 years back or so, PC applications was very, very much the first wave of innovation, so to speak. Then came the web transformation, then came mobile. And now, VMware or Broadcom, I guess now, our take is that AI is going to now be embedded inside all applications. It's going to be a 2 to 5 year somewhere transition, but it's going to be there in every application. It's going to be the expectation that AI is going to be embedded in every application because there's just too many benefits from it. And if you go back and think about, for example, Tanzu, right? Or Kubernetes, I guess. Kubernetes about 10 years back was this shiny object. AI is very similar as well right now. Now there's barely any talk of Kubernetes, right? It's an expectation that your applications are going to be able to support Kubernetes because that's just the way of doing business now. AI is going to be the same way. It's just expected to go a lot faster than 10 years, right? I mean, it's probably we're looking at probably 3 to 5 year transition just because processing power, speed, etc., have just gone in a lot faster. So that's kind of how we expect applications to evolve over the course of the immediate future. One question I get asked when I make this presentation: is AI a brand new thing? Was ChatGPT the first time AI was invented? That's actually not true at all. AI is right now all around us. It's everywhere already. Even prior to ChatGPT, AI has existed for 30 to 50 years easily. There's been specialized AI models based on data analytics and just a ton of data, which gives data scientists the capability to give very intelligent answers to customers. And that's what we call predictive AI. Predictive AI is basically just specialized AI models. It's focused on specific solutions. For example, 30 to 50 years back, at least, fraud detection has been going on. Credit calculations, credit rating calculations, etc. They've been going on forever, right? I mean, at least 50 years to the best of my knowledge. So those are all AI-based models, and that's what predictive AI is all about, right? And it's, again, very specialized, focuses on specific use cases, but that's what predictive AI is. Weather is another big example of that. Weather models are actually predictive AI. They've been there for a long time now, based on a ton of data and doing a whole bunch of predictive analytics based on just a ton of data. So AI has actually been there forever. Now, the big buzzword, I guess, so to speak, at this point is generative AI. And generative AI is the generation of text and images from data, right? Just getting a whole bunch of data and then using that data to generate text, images, so that gives you better answers for whatever queries have been put in. So that is generative AI. It, obviously ChatGPT, that's the big one there. And it's based on large language models. And large language models, through natural language interaction and just APIs built in, is where it gives you all these very great big answers. And large language models are freely available. They're also proprietary, and they can also built in from scratch, right? And a lot of these universities and companies like Google, Facebook routinely release large language models. In fact, one of the biggest ones that's being used very widely is Llama 2. That was released by Meta or Facebook about a year back or so. And that was the game changer because it gave customers the ability to, or data scientists and vendors like ourselves, to use that for commercial licenses. That was the game changer. So Llama 2 is that large language models. Now, I'm a marketer. Shock and awe is the way to go, right? I always want to throw big numbers, right? It's part of what our job is, so to speak, as marketing folks. So there's the big number right there, 4.4 trillion annual economic value. That's a survey that McKinsey did and said by 2028, 5 years from now, give or take, the annual economic value from generative AI is going to be 4.4 trillion. And that's, if you think about what that means, it's from the infrastructure spend, from the software spend, and from what companies will do to get those phenomenal efficiencies. And from those efficiencies, companies will be able to generate a lot of value. And all of that combined is the way McKinsey modeled this and said 5 years, this is the annual value, and annual additional value that will be created out of generative AI. So if you think about it, it's a phenomenally big number, right? Like it's massive. All of these departments that you see on the left-hand side will benefit a lot from generative AI. If you think about marketing, for example, where I work, there's a ton of times we have to do a lot of redundant work, for lack of better words, right? We'll create messaging for a specific product, and then we'll go spin it up in social media or write blog posts or videos, etc. And those are could easily be automated, right? If the right amount of tools or the right tools were available. That's where generative AI steps in and gives you these tremendous capabilities. If you think about supply chain, first half of my career was spent in supply chain. And in supply chain, one of the biggest questions we always had is, what's the orders today? Where are those orders in the supply chain? Do I have the right parts, right, to fulfill those orders? Because there was SLAs that the customer expects. And we had this specialist team who would go on and look at that entire supply chain and try to figure out what parts are where and try to come up with some manual ways to forecast when they could start fulfilling certain amount of orders. What if a model was existed that did all of that work for you? All you got to put in is order number XYZ, right? How do we should I start it today? Phenomenal amounts of ability to take out redundancy. And looks most importantly, right? We're in the IT industry. Let's talk about IT for a second. Code generation has started to dramatically change today because of generative AI. In fact, some of the data points that I'm seeing is companies that have already adopted generative AI are seeing 70 to 80% efficiencies by not having to write basic levels of code, right? Almost 70%. So a lot of the coders are now spending time reviewing the code that's already been written by the generative AI model. So it's just transformative what generative AI is going to do to all of these different departments. And all of these different industries that you see on the screen, right? They're all racing at this point to either investigate or adopt, right? Generative AI, right? Because all of them know that there's just tremendous amounts of applications of this, and you can look through this like fraud detection, personalized banking, investment insights, etc. They just I'm just picking up finance for an example, but really all of these industries have some very, very dramatic things that they see potential with generative AI. They want to adopt it, right? And they're racing at this point to figure their path out through this, generative AI capability, so to speak. However, customers have been telling us, Broadcom, VMware, obviously the first, before the last 3 months or so, that they are very concerned about the privacy challenges that come with generative AI. AI in general is focused on taking a ton of data and taking that data to improve your next answer, whether it's generative AI, whether it's predictive AI. That's just the way AI works. So if you think about it, when you give an AI model a lot of your data, there's a whole bunch of privacy concerns that come up, right? Whether that data is who's accessing the data, right? Whether that data can result in intellectual property getting lost, your customer data getting lost. So those are the kind of concerns that customers are telling us why even though they're racing to kind of go to generative AI, they're still hesitant, right? That they see this big concern with AI and generative AI particularly. Then there's other challenges that they see. Now that AI has achieved its, iPhone moment, so to speak, right? Or its moment of transition now to mainstream, all of them want to jump on AI, but they're very concerned about the choice issues, right? Even though AI is now getting to inculcate everywhere now, generative AI and predictive AI, the customers are concerned that if they go on a journey of rushing to building AI models, etc., they may get stuck with the wrong vendors. They may choose the wrong large language models, which they get stuck with and can never rotate to something else, right? Because as you know, technology moves fast. The large language models that are available today are definitely not going to be the ones that we're going to probably use 3 years from now, right? Or high likelihood we won't. So both vendors and large language models are very critical, and customers don't want to get stuck with the wrong LLMs or the vendors. Now, if you do get stuck with the wrong vendors, costs can go up dramatically. Obviously, always a concern with customers. Now, AI, because it involves a lot of data, requires a lot of infrastructure and has a lot of infrastructure performance issues, potentially, right? So performance remains on top of the customer's mind today. And again, if you give AI all your data, then compliance becomes a big issue. So, these are the prime concerns that customers are looking at when they're looking for, stopping, so to speak, or it's slowing down a little bit about how fast they want to get to AI and generative AI. And this is why VMware announced VMware Private AI. It is an architectural approach that balances the gains of AI, but it's a privacy and a compliance first approach. So what we're telling customers is we're going to give your privacy and your compliance the number one focus, and all the other business gains that come from it you're gonna get, but we're gonna focus always on privacy and compliance first. So privacy first approach. Excuse me. The other piece is it's democratizing generative AI and AI, right? AI is hard, even though everybody wants to get on AI, people are not sure about how to make it there, right? AI should not be limited to just large enterprise with large budgets. We want to democratize AI and generative AI for all customers. Because if you do, right, customers can focus on actually using AI and generative AI and really innovate, focus their energies on innovating versus just trying to be an IT house managing this complex new workload. Now, VMware Private AI, like I mentioned, right, it's an architectural approach, a very highly engineered approach. Hundreds and hundreds of engineers have worked together on it. And if you look over here, this is our ecosystem with which we have had partnerships that we've developed over the course of several years or so, signed contracts, signed agreements to launch VMware Private AI using all of these different ecosystem partners. So if you see, this is a very impressive list. It's a pretty vast list because this list has all the AI vendors that are on top of the people's mind, as well as these vendors it takes time to build this kind of an ecosystem. We already have that, right? Then if you look at the very bottom, right, it's VMware Cloud Foundation. That is the infrastructural platform that forms the base of VMware Private AI, right? VMware VCF gives you all the infrastructure capabilities for VMware, and then all of these different vendors sitting on top give you this private AI, private AI open ecosystem that gives the customers the capability to choose the path that they want, because choice is number one. If you remember, aside from privacy, choice is the next thing that we want to give to customers. They need to be able to decide their paths to AI and generative AI. Very recently, Gartner named VMware a leader in the Magic Quadrant report for distributed hybrid infrastructure. And if you see here, this is basically VCF, right? It's the 2023 Product of the Year finalist in the hybrid cloud category, and it shows up in this top leader quadrant. So this is a big thumbs up from Gartner as the capabilities of VCF, and that's why we're so thrilled about being able to offer VCF as the base infrastructural platform on which you can build your infrastructure, AI infrastructure. Now, key benefits, right? As I kind of mentioned, broad AI ecosystem of partners gives you that flexibility of choice. The fact that you have VMware and all of these industry leaders gives the comfort that you can have data IP leakage, model accuracy, those issues get addressed, right? Which is now a big discussion point in the AI space. NVIDIA and VMware, and now Intel also, we have inbuilt infrastructure, inbuilt capabilities and integrated capabilities with our software to give top performance for AI models, which obviously is a big concern if you remember going back a few slides to the performance challenges. And finally, at the end of the day, AI and generative AI gives the ability to provide big productivity benefits, and that's what our platform, VMware Private AI, delivers to customers. The ability to take out redundant tasks and give this huge boost to productivity so customers can get phenomenal amount of productivity gains and really innovate to the business, which is the big promise of Private AI. Reference architecture for VMware Private AI. If you want to go the open source route, here is reference architecture. The link is at the bottom of the slide. I will share the slide as soon as we get done here. This particular reference architecture is available right now. You can choose this and go. Customers can go their own journey on doing Private AI, and then there's obviously the other offerings we'll share here in a minute. So, VMware Private AI with Intel. So we made 2 announcements in Barcelona last year in November for VMware Private AI with Intel and IBM and NVIDIA. Like I mentioned, Justin will cover here shortly. VMware Private AI with Intel. This is our platform this is our offering with Intel. It is unlock AI everywhere. AI everywhere means VMware and VCF are embedded in most data centers today. Like VMware has 500,000 customers. So that's a lot of customers already that are using VMware. So if you get an infrastructure from VMware, you have this big comfort of leveraging a platform that's available widely. Similarly, Intel CPUs are embedded in all data centers, right? It's pretty much industry standard at this point. Intel's Xeon 4th gen, Sapphire Rapids, and now 5th gen as well is the ones on which Private AI with Intel is enabled. Private Gen 4 Xeon is about 1 million or so CPUs deployed worldwide. So it's widely being used already. It has embedded hardware accelerators and software accelerators, which give this phenomenal capability to actually do AI with just CPUs. So that's a very important point to know, right? Is Intel's platform is right now enabled to do actually AI very well just with CPUs. Now, saying that, GPU support is coming soon as well. But if customers don't want to spend a ton of money doing some wide deployments for AI, then they can just jump on and start deploying this using Intel. And that's why we say unlock AI everywhere, because Intel and VMware are everywhere. On the top, privacy and security first models, like I explained earlier. Boost AI performance because of those hardware accelerators that I just mentioned about embedded inside Intel processors and capabilities inside VCF. You have top level performance with Private AI with Intel. Now let's go into each three of those bullets as like I was explaining. Privacy and security for your AI models. If you see, VCF is VMware's VMware vSphere or VMware vSphere Foundation now, as the new name is, plus NSX plus vSAN, plus basically every capability at this point that VMware has that's part of VCF. And VCF has these embedded privacy and security capabilities of inside each one of their components, right? So vSphere, for example, delivers enhanced security. It has these modern identity and access management capabilities. And then NSX delivers the microsegmentation, advanced threat protection. So your workloads are isolated and cannot easily data cannot leak to the other to anything else, right? So without like listing, calling out each one of these, like these capabilities exist inside inside vSphere and NSX today, and that gives you that privacy and security for your AI models. Boost AI performance, I think we talked a little bit about it. Gen 4 Xeon, with Lava 2, Intel Max CV series GPU. So I talked a lot about the CPUs, but I want to give laser focus on GPUs for a second. GPU support is coming very soon, sometime, I think, middle of this year. So when that happens, customers can start with traditional AI right now, right? And they can start with small level large language models today on their CPUs. And as their infrastructure grows, GPU support will get added on soon here. So at that point, they can deploy GPUs if that's what they want to use to build massive large language models, because if that's what their application desires, right? So there's those capabilities available inside this offering. And with GPUs support getting added on soon, we'll have those GPU capabilities as well for massive workloads. DRS and resource pooling. So these are capabilities inside vSphere, for example, and in general to put workloads at the right spot, so you don't have two workloads separated out too far away, because that will reduce performance. So that's just an example of the phenomenal capabilities inside VCF to really accelerate AI performance. Support for UXL Foundation. So we're really happy about this. So VMware and Intel, VMware by Broadcom and Intel have our support have launched this with a bunch of other partners as well, called UXL Foundation. UXL Foundation takes the approach to it's an open standard for heterogeneous architecture. So basically what it means is, even if you use different kinds of software and hardware, you should be able to deploy AI very seamlessly. So we're taking the lead with Intel on this as founding members of UXL Foundation. And similarly, there's a lot of other companies as well. We're joining hands so that so customers can choose, going back to the point of choice, right? They can choose their journey of AI, choose the vendors of their choice, and get the best level AI performance. So that's kind of the way to understand what this UXL Foundation is all about. Get AI everywhere. I think I talked a lot about it everywhere about this. Intel is everywhere, VMware is everywhere, and then with Intel's AI software suite, and we'll talk about this here in a second, it gives the capabilities to package and containerize AI software. We'll talk about that in just 1 second. VMware Private AI with Intel. So this is kind of important, right? Is VMware Private AI with Intel has 4 key use cases. While we see a ton of use cases for AI and Gen AI, excuse me, these are the 4 top use cases. Code generation, I talked a little bit about that in the beginning of the call. Coders can get the capability to do dramatic amounts of time reduction in coding. Contact centers resolution, contact centers and customer service. There's a lot of struggles today in getting the right answers very quickly to the customer, or solving issues very quickly for contact centers. So there's a phenomenal promise with AI and Gen AI to get the right answers quickly and get to the right solutions to solve problems very quickly. So that's contact centers. Classical machine learning and recommendation engine. This is where the Intel solution has a great strength, because this is the predictive AI example that I was talking about in the beginning, right? This is the classical machine learning, the recommendation engines, etc., where AI's Intel CPUs do a phenomenal job, right? So that's where these use cases are very well enabled with VMware Private AI with Intel. A little bit about let's build this out. Actually, hold on for a second. All right, so sorry, let's just build it out then. VMware Private AI with Intel, if you look at the very bottom, it's VCF on top of Intel Xeon CPUs, Intel Max GPUs, and Dell Technologies, HP, Lenovo as the supported infrastructure software. VCF comes with all of these capabilities. We talked a little bit about each one of these to give really good performance for AI, right? And give you all the privacy and security benefits. If you look at this is Intel's AI software suite, and this gives capabilities for data analytics, classical ML, Gen AI, deploy, etc. This is a new AI software suite that Intel has recently launched, and this gives the capability to put together those AI models which customers are looking for. And at the very top, if you look here, NLP, price prediction, fraud detection, these are the classical machine learning models like I was talking about, right, where Intel has a great strength. So that's why we're positioning these as a phenomenal way to kind of, phenomenal use cases there. And on the right-hand side is the traditional generative AI. I guess I shouldn't say traditional, but this is really generative AI use cases. So with Intel's AI software suite, whether you're choosing traditional AI or whether you're using large language models, right, basically Gen AI, you have that capability to do both, right? So that's the big thing about this architecture. And then any scale, Hugging Face, Converge IO, these are industry leaders in the ML ops and the LLM space, right? So that's what Private AI with Intel architecture looks like. Now let's move on to the second offering, which is VMware Private AI with IBM. Very similar to what I mentioned in VMware Private AI with Intel. It's a privacy and security sits on the very top. What the big promise of IBM, the IBM offering with VMware Private AI with IBM is it gives the ability to deploy IBM Watson X on premises to build your AI models, right? So there's a lot of customers who are already using IBM Watson Cloud, right? And now they get this ability to now deploy AI models and, on their own premises as well using IBM Watson. So that's the big promise here, right? And it's privacy and security first always. You get the choice of deployment location for your AI model. So IBM Cloud is already available. Now IBM Watson on premises can also be deployed, right? And it gives you the ability for a wide choice of LLMs, right? Just like other models, just like other solutions. Sorry, just like just sorry about that. I'm getting texts. Just like the other solution with Intel, and very soon Justin's going to talk about the NVIDIA. It gives customers the ability to deploy large language models, whether it's open source through Hugging Face or IBM trained foundation models or third-party models as well. So big choice again, and it gives the ability to deploy IBM Watson on premises. So you can just skip this slide, but really over here is privacy and security for your AI models. Watson X, delivers trusted AI, right? It gives very good governance capabilities for AI. And vSphere delivers the enhanced security. NSX delivers the network security. So we talked a little bit about that in the Intel offering as well. But IBM brings in its own angle of privacy as well. So now you have privacy at both the infrastructure level as well as at the model level. IBM Watson, I think we talked a little bit about that as well. IBM Watson is the AI and data platform that's built for business. It's widely used, and now it's on its second generation, pretty much. Like the first generation of IBM Watson was launched 2010, if I'm not mistaken. Now it's on this massive recode, and it's been relaunched about 3 to 5 years back or so. You get the ability to do training, validation, tuning, and deployment of your AI models, both on premises and on cloud with this offering, right? A lot of the customers are already using IBM Watson on cloud, and now you get the ability to do it on premises as well. And VCF provides that multi-cloud infrastructure layer. So whether a customer wants to do it on premises now or on the IBM cloud, the VCF being a multi-cloud infrastructure layer is very well set up to handle this kind of workload. Wide choice of LLMs. Already talked a little bit about that, whether it's third-party, open source, or proprietary. All of those options are available. So basically, really high choice here. And here's what the infrastructure for VMware Private AI with IBM looks like. VCF at the very bottom infrastructure layer, and on top of it, Red Hat OpenShift for your Kubernetes layer, and then finally Watson X for building those AI models, right? And all the big names like Hugging Face, PyTorch, etc., are supported. So that's what the infrastructure is for VMware Private AI with IBM. Is just very similarly, like on the Intel side, you had the Intel AI software suite. Over here, you have the Watson X software. And with that, I'm going to hand this off to Justin for walking us through the NVIDIA offering and taking us home.
Thanks very much, Shobhit. I'll share my desktop now if you'll stop sharing, please.
Sure.
Thank you. Okay. So that was a great description by Shobhit there of the two offerings from Intel and IBM. I'm going to delve into, in a little more detail now, the NVIDIA partnership. And this partnership has been around for a surprisingly long period of time. Somebody said to me yesterday, I'm surprised that there's been so much history of work between these two companies. Didn't know that we've been virtualizing GPUs, for example, for more than 10 years now. It started in 2013. And you can see the progression there. I won't go into them all, but we've been cooperating and partnering with Intel for close on 3 years now on AI/ML. And one result of that is NVIDIA AI Enterprise on vSphere. It was the first platform to support that. We also worked with them closely on multi-node distributed training, which you can think of as the very high end of machine learning. And now for the past 6-9 months or so, we've been working in partnership with NVIDIA at the engineering level, as well as the go-to-market level, on improving VCF, adding new features into VCF and vSphere to make it a better platform for the Gen AI applications that we're going to talk about here. So the architecture with NVIDIA is probably familiar to you already. You've possibly seen this from some of the announcements, but there are essentially 5 layers in it. So Shobhit has already described the partnership with various hardware OEMs, Dell, HPE, Lenovo. That's ongoing, of course, and they're validating this architecture on top of their particular servers. Dell XE9680, for example, high-end server with 4 GPUs or even 8 GPUs in it is being validated as we speak. VMware Cloud Foundation is the core of it all. And NVIDIA has been shipping the AI enterprise suite of software, including their virtual GPU drivers and their data science tools, for close on 2 years now. So it's not at version 1 anymore. It's at version 4 or 5 now. So that software is included in this architecture at the top layer there in the green area. And that will continue to be shipped by NVIDIA. We're working closely with them on it. And we've actually done quite a bit of additional features. We're working on those features for VCF, like deep learning VMs, vector databases, GPU scaling, and many, many other features for provisioning virtual machines in a VCF environment for Gen AI particularly. And I'll delve into some of these now. I'm going to leave the NVIDIA layer to the back end and just talk about one aspect of that, but I'll delve into what these things are that we're doing at VMware to make Gen AI better for you and to make it easier. And, you know, what we found is that people are using those models that Shobhit talked about, Llama 2, Mistral, Falcon models, as you see there at the top. There's a huge advantage of those, and I'll talk about that advantage coming up in a second. The use cases we've basically already described, information retrieval and processing of information, so that somebody at the end of the phone, for example, can generate a paragraph or two to guide them in answering a question if they're in a contact center or if they're just on a customer call. You know, that sort of application we think is going to be a killer application here, along with code generation. Those two in particular stand out, but there are others as well. So I mentioned those open source, commercially viable models. These are coming from various sources, from research institutions like Falcon from the TTI Research Institute, TII Research Institution, Llama from Facebook, Shobhit mentioned, MPT from a company called Mosaic that actually got acquired by Databricks recently, and NVIDIA has its own models that it's trained itself. The point about these is somebody else has done the hard work of pre-training these models for you. They have taken the Wikipedia, the Encyclopedia Britannica of this world of information and fed that information into the model already. So it's pre-trained. You're not going to be spending months and months with thousands of GPUs doing all that pre-training work. You're going to stand on the shoulders of these giants here and customize these models for your own private data. Effectively, take the weights or whatever is deliverable from these models, and we took Llama 2, for example, in a demo that I'll show you. Take those models in pre-trained form, provided they have a commercially usable license, and provided that they have been tested by you or by us, and customize them with your own private data. It's the private data that really gives an advantage to your industry or to your business when you use one of these models to answer questions that only you can answer, essentially. So looking now at that blue layer in particular and looking into the vector database area first as an interesting area, we think we have a shortcut for you here to adopt generative AI in a private AI style, such that you can do this in short order with actually not too much infrastructure at all, not too many GPUs. It's not as if you have to go and buy a dozen GPUs to do this. So let me delve into that example to begin with. And essentially what we're talking about with vector databases, and we're shipping one of those, it's called PG Vector. The vector database is at the bottom of the diagram on the right-hand side. Essentially what we're doing is having the model look up a database for data that it's never known about before. The model is trained by the data scientists for weeks or months, and it's trained on a specific set of data. But once the model goes out into production, there is new data coming up in the world, and the model does not necessarily know about it. So what this is a technique to bring your model more up to date by having it retrieve data using something called a semantic search from a vector database or knowledge base at the bottom here. And you'll see this in action in a few minutes here when I show you my lab. But essentially, your user query is coming in via the model to retrieve data from the database. And then the database is feeding back a small set of documents to the model and saying, here are all the pertinent documents that I see that refer to VMware or Llama Index or some term that it's not known about before. And then the model is reconstructing the answer from that to summarize it for your customer-facing person. So this is connecting your model to a database. Now, this is not the only technique you can use to customize your Llama 2 or your Falcon. You could use domain-specific fine-tuning. That's one technique. You could alter the arguments of your model. The temperature is how sensitive the model is to different answers, for example, or the length is the amount of text that it can take as a query or provide you as an answer. You can add a prompt in to the model to tell it, if you don't have the information, don't invent a new answer of your own. Don't give false information. Just tell me you don't know. We want to avoid models giving hypothetical answers to questions. But a technique that's relatively new called retrieval augmented generation, or RAG, is a technique that I've just described, which is to take the model and have it look up an external knowledge base, which you are keeping up to date, to give it insight into data that it may not have known about at training time. And that's a technique that's becoming hugely popular now in the data science world, and we'll dig into it in a little more detail here. So effectively, a user in the client application in the middle there at point 1 asks a question. We're going to call that a prompt. Tell me what's new in vSphere 8 update 2 or update 3, for example. And only a VMware person could answer that. So the query goes to the vector database and it retrieves all of the knowledge base articles that refer to that particular subject, hands them back to the client application, and that application now sends them into the large language model, which massages those answers, those documents, into a respectable response. So you can see here that the large language model is cooperating with the vector database to generate the data. So that's the outline. There's more to it than this, but that's the outline of how this retrieval augmented generation works. And of course, we've got technology to give you here. There is plenty of open source technology around to do it, but our technology is based on Postgres, distributed Postgres called Greenplum. And on top of that, we've layered another API, another library called PG Vector, Postgres Vector for vector database. And here we're loading in all of the up-to-date internal text here. These are private data that are private to our company at the bottom of the left-hand side. We're loading that in ahead of time into the database, perhaps on a weekly, daily, or hourly basis. We're updating that. And so when the user asks their query in point 3 at the top there, that query goes to the vector database first, returns the retrieved documents. And now in point 5, those documents are being sent to Llama 2, a model that we've deployed. And then Llama 2 is saying, well, I understand all these texts now. I'm going to generate a response to the end user, number 7 there, such that they've got the very latest data about a subject that Llama 2 was not trained on, for example. So this is a way of securing your data, firstly, in that database, but it's also a way of keeping the data bang up to date, very much up to date this way. And so that's one component that we ship in the private AI foundation with NVIDIA that'll be coming early in 2024 on top of VMware Cloud Foundation. Deep learning VMs, as you can guess, are VMs with pre-built tooling in them, Python 3, Llama 2 even, that sort of thing built into them, such that you have your drivers already to start work, and you can provision those deep learning VMs very quickly through ARIA automation or even through Kubernetes if you wanted to. Now let's look at GPUs and GPU scaling. And very briefly here, we've been telling you for some time now that you can go down two paths when you use your GPUs. You can go down the dynamic direct path IO method of using a GPU, and you can have multiple GPUs assigned to one VM that way, but your GPUs are not shared in any way. They're dedicated to one VM. On the contrary, you can use NVIDIA Virtual GPU, which is built into the NVIDIA AI Enterprise. And this way, you can also use multiple GPUs on one VM, but you can also share a single GPU across multiple VMs. And there are two techniques for doing that: time slicing and MIG, or multi-instance GPU. This is old news. This has been around for a while, but what we've added to it over the past months and over the past releases of VMware Cloud Foundation are more sophisticated understanding of generative AI relevant setups for GPUs. So an NVLink is an NVIDIA technology that we now understand inside vSphere and VCF, such that you can add two GPUs to a VM in one action. And those GPUs have highly optimized connection technology that you see on the top there, NVLink bridges, that allow them to act as one. And the reason for this is some of these models actually need more memory than some of our GPUs have. Our older A100s have 40 gigabytes, the newer ones have 80 gigabytes of frame buffer memory. We can easily consume 40 gigabytes of memory using Llama 2, 13 billion parameter model, for example. So we're going to do more and more of this as the models get bigger and bigger, and we want to cater for more of them inside vSphere. Not only two GPUs, but there are models in existence now, the high-end Dell, the high-end HP, the high-end Supermicro models, that have inside them a board called the HGX board, which is an NVIDIA standard board that has up to eight GPUs on it, up to 8 H100s in some cases. And that's a very high-end system, but we now support that on vSphere, including support for the NV switch, which is high-speed technology between the GPUs there, so that they can operate at 450 gigabytes per second, as opposed to the PCI speeds of 1/10 of that. Now, we can break this setup, of course, into smaller sets like 2 GPUs or 4 GPUs and allocate those as a set to a VM. So we can share this high-end server across multiple VMs, of course. And the benefits of using that NVLink technology are very clear from this performance graph here that shows a Dell PowerEdge XE8545 with 2 sockets and 32 cores here, with 1 GPU, 2 GPUs, and 4 GPUs. And these are virtual GPUs. These are using the virtual GPU software from NVIDIA on top of VMware Cloud Foundation. And you can see here with 4, you're almost quadrupling, well, you're at least doubling and trebling your performance by using the NVLink or NVLink bridges between the GPUs that you have. So this is definitely a technology to consider for optimizing your performance in generative AI. Likewise, for some time now, we've been working with GPU Direct RDMA, a technology from NVIDIA also built into their drivers that allows us to take the long path on the left-hand side and shorten it, seen in the red arrows there, where data coming in over your network card might have to go up to the CPU, over to system memory, back down to the PCIe switch, and then to the GPU. Instead, the data can go directly from the NIC card to the GPU and vice versa, without involving the CPU, without involving system memory. This is clearly an optimization path for distributed applications that use GPUs across the network, where the GPUs are swapping information across the network in a distributed application. So this has been around now for quite some time. We're improving it every time we release new drivers. you're going to see H100 with NV switch support in an upcoming flavor of VCF. We're capable of handling very large workloads if need be, is what you should take away from this. And the means in which we make that simpler is to construct a device group out of that pair of GPUs that have NVLink between the two of them, or a device group that is composed of a NIC card and a GPU that happen to be sharing the same PCIe switch. And there will be more of these device groups as we move forward. Device groups are a technique to be used by the admin to say, I have this unit, I'm dealing with a customer demand here to have a very high performance situation. I can add that unit in the hardware to my VM without too much trouble at all. Just add it as a PCIe device. One quick look at the NVIDIA software here. I'll focus in on Triton because that's the opposite end of the spectrum to where we've been talking about training and customizing. This is the deployment time. Triton Inference Server and Triton Management Server work together to give you a scalable inference platform for your model. That is putting your model now into production. It has been trained, it has been customized, it's now ready to go into production. And on the right-hand side here, you see end-user applications operating against a model, maybe more than one model, and they're sending queries into the model and getting results from it. But behind the scenes, those models are hosted on a collection of Triton inference servers, which are managed by the Triton Management Service, a new feature in NVIDIA's AI Enterprise Suite. And these models, of course, will be optimized themselves. Techniques like quantization and fusion of the layers within the neural network that makes up the model, those techniques are well understood now for large language models. So TensorRT is, if you like, an optimization technology that takes your model and squeezes it down into tighter memory spaces, such that more models can be used on your GPUs. Those two technologies have been integrated together by NVIDIA now, and TensorRT for LLM, for large language models, is now a new feature that comes specifically for generative AI applications. The point here is that you can scale out very quickly your single model or multiple models. You might have a star coder model, for example, for code generation, and a Llama 2 model for customer query answers, for document summarization, that type of thing. Those models need to be separated from each other, but at the same time scalable across your Triton inference servers. And I'm going to show you this Triton inference server here in a second. So just a quick summary, there are lots of resources for you to use here. I'll bring that slide back up a little later, but your call to action as a result of attending our webinar here is really to look at that private AI reference architecture white paper and delve into it in more detail, in more technical detail, and look at the press releases and the other documents from us with NVIDIA and the other partners, such that you can learn more about this private AI work with NVIDIA, private AI foundation with NVIDIA. So rather than give you a lot more slides, what I'm going to do in the remaining minutes is give you a quick demo. So for this, I'll jump into my lab here. And this is an answer to the question, where do I get started with this generative AI stuff? How do I get something up and running fairly quickly? And NVIDIA and ourselves had conversations about that. And as I mentioned in my talk, retrieval augmented generation is an interesting technique to connect up modern databases into your large language model. So what NVIDIA did was built a sample application based on that idea. They call it the knowledge-based Q&A chatbot. And that's all running in this single VM here, RAG workflow, retrieval augmented generation workflow. And you can see it's running across my servers in my data center here. And there's nothing really that special about this VM. It's not got huge memory. It's not got huge storage. But what it does have is two Grid A140Cs here on the right-hand side. That's a device group that I was talking to you about that allows me to specify two A100s have an NVLink between them. And I specified that as one unit when I was constructing this VM. And I constructed this virtual machine by hand. I'm going to show you some technology that we're working on for automating the process of giving that VM, creating that VM, and giving it to a data scientist, because a data scientist doesn't really care about VMs. They care about their application development environment, particularly a notebook, a Jupyter notebook. And this is what a Jupyter notebook looks like. This is built into the NVIDIA sample application here, the Q&A chatbot that I talked about. And you get hold of this. I won't delve into the code with you on this case, but what I will show you is the application that this setup is hosting, that single VM is hosting. And this is an example chatbot. It's based on Llama 2 7 billion. And I'm going to ask it a quick question here. What is Llama Index? Which is a component actually of the background to this application. And what does my chatbot tell me? Okay, it's telling me, based on the provided context, I can confirm that Llama Index is a technology which is connecting large language models to various data sources. Now that's using the knowledge base. And using the knowledge base is using a vector database behind the scenes, an open source vector database in this case. If I switch this off now, and so ask the same question again, what is Llama Index? So now we're not using the vector database that I talked about in retrieval augmented generation. We're just using the model. And so you can see there's been a degradation in the answer. I'm a large language model. I'm afraid I don't know the answer, at least it's being honest. So it doesn't know enough to answer your question, as opposed to when I ask it, with the knowledge base on, it says based on the provided context. The provided context is the database lookup, and I can show you that. Over on the right-hand side, it's in JSON format. It's not very friendly, but there is the set of things that I gave the database ahead of time to tell it more about a particular subject area here from NVIDIA. I loaded in some documents from NVIDIA here into the database ahead of time. So that's very interesting. That's a sample application that could be your starter application. All of the code for this is available, and you can get hold of it. If we were to look inside my VM that I showed you in the vCenter interface just now, this VM here, this RAG workflow. If I look inside it, I'm logged into it now, and I want to see what's going on exactly. And as I mentioned, I used 2 GPUs here, and you can see the GPUs at the bottom, GPU 0 and GPU 1. They're running the Triton inference server. There are 2 copies of Triton inference server. There's a small second Triton inference server process. It's a back-end process. So there are 2 processes for each Triton inference server. But you can see there are 2 of them running here with Python across my 2 Grid A140C GPUs that you see at the top. And you can see I'm using about 35 gigabytes of the total 40 gigabytes on those. These are older A100s with just 40 gigabytes on them. So that's using the NVIDIA SMI tool to see what happens. If I look exactly at what those processes are and say Docker PS-A, you can see that this application is just made up of 6 very, very straightforward containers. The containers' names give them away on the right-hand side here. The playground is the sample GUI that I used when I asked my questions. Query router is simply as its name implies. And Milvus is a vector database that happens to use MinIO and etcd behind the scenes as supporting technology. But the key technology here from NVIDIA is the Triton inference server that's supporting this model, the Llama 2 model that I've deployed. So that's a quick look at what a VMware infrastructure person would see. And you can delve into this in more detail quite easily. You can get the instructions from us to build all that. How about if I wanted even more automation? If I wanted to do this using technology from VMware called ARIA Automation. And here's a quick recorded 2-minute demo on how you might do that. As you can see here, we have a quick start within ARIA Automation now that allows you to create a template deployment effectively that will be used by data scientists to ask for their own VMs. And what I'm doing here is creating exactly that, and I'm telling it various details about NVIDIA licensing here, such that when I create this eventual deployment, it will be licensed. And I'm specifying the size of the VM here and which images. These are the deep learning images that I mentioned. And I'm specifying I want them medium and large. I'm basically sizing my VMs here with different vGPU profiles that you saw earlier. And I'm selecting the storage and where it's going to get the containers from. And I give it a name, tell it what the administrator is, and what that person will be doing. And I'm specifying here every detail that would be needed in order for a data scientist to say, I want a deployment of a workstation like the one I showed you. So you can see here that ARIA Automation is building that catalog item such that now the data scientist can go into their service broker, their broker for VMs that you've supplied to them. And from a catalog, which we'll see here, you can see multiple copies of this workstation deployment that I built. They're now asking for a new advanced machine learning workstation with eight CPUs, 182 gigabytes of memory, and a V108C vGPU profile there in the middle. And they're asking for PyTorch, TensorFlow, whatever tools they want that have been built into the catalog already. There's an API key to allow access to the appropriate containers, like the containers that I used in my application. And they simply say submit, and off you go. You've got your workflow all set up for you. So let me stop there, go back to the reference slide, and put that up for a few minutes while we take some questions live. Thank you for your time. Just reading through the Q&A here. Can the data in the Broadcom VMware LLM be encrypted by customer provided keys? I'm asking this question the second time because okay. We're working on encrypting data. Effectively, when the model is trained, the model is capable of dealing with data in the clear, but on the way into the model, we can encrypt the data. And when the data goes across the network, we can encrypt the data. So encryption is an evolving technology for us here. But I see your point, Stephen. It is necessary that we encrypt the customer data. And remember, what we're doing here is not feeding massive quantities of the data into the model in pre-training mode. We're fine-tuning those already pre-trained models with smaller quantities of data, like KB articles from VMware on vSphere 8, for example, which can be encrypted when they go into the vector database, but would need to be decrypted on entering the model. Yes. Great question.
And then just to add to what Justin just said, right? Like a lot of this technology is in development, right? So we can't really commit to any newer facility, functionalities, stuff like that. As soon as over the course of next, few months, when the NVIDIA offering launches, we're going to be able to come out with a lot of these incremental functionalities where we'll be able to share more information of that level.
Yeah, that's very fair, Shobhit. We're still developing a lot of this work. So, the features I showed you in ARIA Automation may change a little when you see them, but that little demo that I gave you on the NVIDIA Q&A chatbot is available today. You could download that today from NVIDIA and get started, even on vSphere 8 Update 2 with your GPUs there. That's a way to get started in working with this today.
And then just to add to what Justin said, right? Like a ton of this development's already happened. Like we're very, very close to going like general availability here soon enough, right? In the next, quarter or so, couple of quarters at the very maximum. So at this point, we're inviting people to come in for any early access and those kind of partnerships, right? So if you or your customers have needs, come to us. We already have a huge pipeline right now at this point of people who are helping and developing. So not everything here that we've shared is in development. There's like a ton of development that's already happened. We're in early access in most of these places and ready for business, right? So bring it on and we'll help you get started.
And as mentioned, if you want to educate your folks on what it takes to build a full-fledged architecture, there's that third bullet point on this slide here. The reference architecture document is published. It is public. You can get it through your TAM. And I'd strongly recommend taking a look there, although you don't have to build a very, very large architecture to get started. You can start with just 1 or 2 VMs and 1 or 2 GPUs, as you saw in the demo.
That's a very good important point, right? Like customers start thinking that they need this massive infrastructure. That's not true. Vast majority of the needs of the customers can actually happen with just 1 to 4 GPUs at the very maximum, right? And CPU wise, Intel's has this phenomenal CPU based infrastructure, right? So if you don't want to go the GPU route, that's available today as well. So bring it on and we'll get you started.
And I think I see most of the questions answered at this point.
Yeah, Shobhit, Justin, thank you very much. This is very useful content. We appreciate it. I guess we'll go and wrap up the recording, and then if folks have some questions, we can, if folks raise their hand, we can unmute them. But as we mentioned at the beginning, this presentation was recorded. Your TAM can make that recording available to you. Please join us again next month when we'll be looking at RA operations. Thank you.